Hey, boys and girls, ladies and gentlemen. Well, let me check the focus on this thing first. A little more light on the subject. Okay. Well, about a month and a half ago, I got struck by lightning. Well, not me personally. My house did. At least I thought my house did. It scared the heck out of me. I was in the kitchen, and all of a sudden, a big, loud bang, and a flash, and smoke, and yeah, I thought the house took a direct strike. It burnt some electrical wiring in the house. It blew out a bunch of appliances. It did a lot of stuff. Plus, it also destroyed a lot of my ham radio gear. Yeah, the radios all survived. Every radio is intact, but what did blow out was rotor controllers and power supplies and interface panels, and this little thing right here. This is actually a 4 antenna relay box, a remote relay box. You feed your coax cable into here, and there's a switch back in the shack, which I'm in right now, but I won't show it to you right now. And from there I can choose between 4 antennas remotely, and it does it by sending DC down the coax and varying types of DC, polarity and all that. It'll switch a set of relays. Well, I was having some real serious issues with high SWR on the antennas, and I put my analyzer on there, and sure enough, it was like 3.8. That's not good. Put my dummy load at the end of the coax. I've got some hardline. Some Yukon hardline that goes out there, fairly big stuff, and when I put the dummy load on the end of that, it came up at 1.0 SWR, so okay, hardline's good. I even put a megger on there to check to make sure the insulation was fine. It was fine too. So, trace it down to this, and what had happened was, this little coil, which has now been rebuilt, was all black and charred. It's a choke coil, basically, essentially. It blocks the AC from reaching these relays, and so I was either going to have to replace the entire unit, no way, or I'm going to fix it. So I bought some magnet wire, and I rewound this and put some shellac on there and all that kind of good stuff, and so I'm just going to put it back on the board over here and test it. But essentially, yeah, lightning. I have lightning suppressors on everything. On the antennas, on inputs, what have you. But what happened was, and I finally figured it all out after a lot of investigating, I still have one more item that needs to be repaired, and that's the rotor itself. The position sensor is fused. It's my little reed switch, and it's fused shut, so I just have to take the rotor off and replace the little reed switch inside there, and it'll be fine. But lightning hit the tower. It didn't hit the house. It hit my radio tower out about... it's about 200 feet, 220 feet back from the house. It's a fairly tall tower. It's a 20-meter tower, and this has got 15 feet of mast on top of that. So it's about 75 feet high. It's a big target for the antenna, for lightning. No, it's grounded. It's grounded very well. Stakes all over the place. I've got 10-foot grounding rods, several of them in the ground. All legs are grounded to that. But what happened is it hit the tower, jumped to the AC line that's there. I've got a 120 volt plug out at the tower, which is convenient when you're working on your radio gear and you're out there. It's nice to have a source of mains power that you can plug into for a scope or a soldering gun or something. Well, it jumped all of that and into the mains power through there, traveled back into the house, which explains why certain breakers got burnt out, and one of the breakers was the breaker that fed that tower. It burnt out the breakers. It melted some electrical wiring in the house. And that's how it came in. And it hit the mains coming into my Radio Shack. And I've got a very expensive surge suppressor, lightning suppressor, that was feeding every piece of kit. And yet it still jumped that, blew out a 24 volt power supply. But when it did that, it came down the low volt, the 24 volt side, and hit the rotor controller. From the rotor controller, there was a USB cable to the computer, blew out the computer, and then from there, the USB out, and I just cascaded on and on and on. But at any rate, this was one item that I had not considered, but it was the switch. So I'm just going to be soldering this choke back here into the unit, and then I'll test this and put it out in the field. And actually, I do notice I have some charring. I have to Really should check those capacitors as well. But that'll be in a few minutes. So anyways, that's the project for today. Hope you all enjoy it. Okay, just on a quick side note, one of the hardest things I had to do was to try to find out what value this choke is. I couldn't find it easily, but I did manage to finally dig it up by doing a lot of research, and because it's not listed as to what, it just simply says it's a choke. Well, it's 100 millihenries, and because the thing was so charred, I couldn't really tell, you know, how many windings and so on. I could tell the gauge of the wire, but I could tell how much wire was populated on here. So with that, you're pretty close to it. So anyways, after I rewound this, I put this on my LCR meter and tested it, and sure enough, it's 99.8 millihenries, which is awfully damn close. I think that's considered a win, and that will go right back where it came from, and then I will power this thing up and test it. And that should do it. It's just that simple. This is now ready to go back out in the field. This Ameritron RCS-4 relay box. So if you ever have one of these that gets blown up by lightning, well, you know, you might have to replace the capacitors. Those are pretty easy to figure out what size those are. But the choke is 100 millihenries. I use 26 gauge magnet wire, and it consisted of 79 turns. So 79 turns, and it came out with the same value that I found that this choke is supposed to be. So if you have one of these that goes kapui, well, that's your options. You can rebuild these things. Every single part on this board is off the shelf, so it should not be hard to find to rebuild this yourself. You don't have to send it in. You can fix it yourself. It's a pretty simple process. All you need is a soldering station and a tiny, tiny bit of know-how, and that's it. Okay, we're back to the workbench here. Hold on one sec. Okay, we're back to the workbench. I hooked this up to the control box in the ham shack, and antennas 4, 3, and 2 switched smoothly. So as soon as I switched to 10 to 1, all the relays went bzzz. It was telling me there's a problem. And sure enough, I found a blown diode. And it's a very common one. one N4007 general purpose diode. And I just happen to have diodes, voltage regulators, you know, all that kind of stuff, all in a nice little case, labeled. And so I grabbed one on here, and I will be replacing it and testing it again. There are two diodes on the circuit board. One tested good while it was on the board. The other one was a dead short. So I'm just going to replace this one that was a dead short, and then we'll see what happens. So let's get this thing soldered in. Now normally I would remove the entire circuit board from the panel, but that would mean I'd have to remove all of the SO239 chassis mount connectors and all of that. So I'm not going to do that. I'm just going to go ahead and do this the old-fashioned way by simply trimming this wire, bending it to the right length, and inserting it in. Of course, in the proper orientation, which I made note of prior to pulling the other one out. Oh, a little tough to see. Oy. Thank God for editing. Damn. There's going to be some editing going on. Oh, for crying out loud. And that's how easy it is. And that's that. Let's test this. Okay, it works perfectly. However, just as a precaution, I am going to remove the other diode and replace it. Because it also got struck by lightning, and it apparently survived, but like anything solid state, sometimes it doesn't fail right away. It might be a month from now when it says, you know what, I've had enough, and it gives it up. So I'm going to just sit here and remove this diode and replace it. All right, that was easy. Let's try this. Okay. Okay, here's the switch box, and it's on number 4. Let's go to the relays here, see if we can pick it up in the microphone. There's 3, there's 2, there's 1, there's no clatter. And there we go. So from 4, 3, 2, and 1, it switches between these relays. And now it functions. So now it's good to remount out in the field, and it's been tested and operational. So we will give it a shot and see how our antennas perform after we put the switch box back in. Have yourself a great day. This is VE4 Tango Tango Hotel, Peter, 73.